Hi, everybody. Can you hear me? Welcome back from break. I'm here to talk about extending osquery. And as I mentioned on the panel, I hang out a lot in Slack, where I answer questions about how to deploy osquery. A lot of times with things like TLS certificates and logging pipelines and some of the other open source projects that are related to osquery. And over time, being in the community, I kind of developed a favorite topic, which is writing extensions for osquery, and I kind of try to go and tell people that they should do that. And I'll comment on pull requests and be like, this shouldn't be in osquery, you should write and deploy this yourself. And sometimes that's the right answer, sometimes it's not. So before I dive into like how to do this, we should talk a little bit about why. So osquery today ships with over 200 tables, and we mostly discuss osquery in the context of tables. Besides that, there is loggers and config plugins and other features that osquery provides. So those are not included here, but they are extensible. And this is really awesome, like being able to have a static binary that has all this functionality that you can just drop on a host and it works is really awesome. Except for when you think about the fact that somebody has to maintain this. So Apple is known for breaking osquery almost every release because they change things, and they're not alone. Like, especially recently, I've highlighted a few tables here. osquery started accepting tables which are not necessarily something that ships with the OS that osquery is interacting with. Like, for example, Docker is a third-party vendor's product that osquery is now built in. osquery has a carbon black table, has all of this AWS integration, and a lot of us use AWS, but Amazon has broken Kinesis before. And one thing that we all rely on is the stable osquery release, which is signed, and that's what we deploy internally. And so when a third-party vendor breaks an API in a table we depend on, or a logger we depend on, we go and we're like, hey, can you please update osquery and publish a new release? What if you didn't have to do that? So while we were going through the process of I was working at Collide at the time that we were going through the process of the osquery lockdown and code freeze. And honestly, Collide was not affected as much as everybody else because almost everything that we did through extensions. And we were able to, like, oh, this table broke, it's okay, we'll just rewrite it and push it out. And so in terms of like release velocity and stability, we depend on osquery, the core, but not necessarily on all of the quirky functionality that it provides. So like, there's also the problem of like, there's a lot of tables that exist, but they're not always working exactly how you would expect. Like the Python packages one is a good example because it's like, it'll detect packages that are installed in a specific way, but if your developers install the packages in different ways, you're not necessarily going to get that. This is a C++ table. Obviously, somebody who really cares about detecting Python packages probably has Python knowledge, so maybe that should be an external project with a special focus group that is interested in just building that table. Anyway, that's kind of my spiel of, I think osquery is kind of big, and some of these things don't belong in core. Actually, I think in the contributor guidelines that have been published for osquery, one of the touching points is don't write tables that talk to external systems. There's a few exceptions, but that's a topic of conversation that has been in office hours before. Besides that, I have personal things. Like I do not write C++, but I want to develop osquery. So how do I do that? Well, I'm primarily a Go developer, and I want to use Go to maintain osquery. So before I go into that, I guess I should bring up that osquery itself don't run betas. osquery itself is built with an extensible RPC framework called Thrift, also built by Facebook. And if you're not familiar with Thrift, it's similar to protobufs and gRPC, and it allows you to define an API in a language agnostic way, and then have tools that generate code in other languages to communicate between a client and a server, osquery being the server and your plugin being the client. So that means that you could use any language that you want to write a table in osquery or a logger. I'm kind of exaggerating, though, because in reality, it's any language that the Thrift project has released code generation for. Otherwise, you also have to write that. And then when you look at the interface for the Thrift APIs, it's kind of complex. You really need to know a lot about osquery to be able to write a table. Luckily, for a few languages, people have built SDKs specific to those language, idiomatic to those language. The most well-known ones being Python and Go. And today I will be I'll be demonstrating the Go API. But there's also, I think there's a JavaScript one that I've seen around. There's also a Rust one that somebody built at the last year's hackathon. So those are interesting ones to explore. So yeah, how do we do this? So I want to talk today specifically about, spend most time about config and logging plugins. We talk about osquery, we talk a lot about tables. Tables are not very problematic, and especially if you're talking to a system API, there's a good argument for having a table in osquery core because it is C++ and will write some C, talk to some C API. So Go isn't always the best for that. But I interact a lot with cloud infrastructure, and Go is really good, and vendors always release SDKs for Go for interacting with their system. So I get the question a lot in Slack of like, how do I use multiple config sources? Or, I want to talk to the system and so on. And osquery has this concept of a config plugin. Like normally, if you want to deploy osquery configuration, you're using either a server like Fleet or a configuration management tool like Ansible or Chef or Puppet, and you're pushing that JSON blob to your hosts. But if you had, if you wanted to interface directly with GitHub or your own internal system or some database, you can do that in just a few lines of code. So this is what it looks like. The Go plugin at github.com/collide/osquerygo has this package called config, and it has this interface where you have a function called new plugin that takes as an argument the name of the plugin that you are writing and a function that will generate the configs. And this function will return a dictionary where the key is the source of where your config is coming from, and the value is the JSON blob that osquery expects that you've seen on the file system plugin, and so on. And inside that function, you can write any logic that you want. So as an example, I have this osquery config that I posted in a GitHub gist, and it specifies a few options, like this is familiar to anybody who's using osquery. It has a query there, a schedule, and it lives at this URL. So GitHub has, to write this plugin in Go, I will define a structure which will take that just ID that I highlighted from the URL as configuration, and it will use the GitHub client because there's a really good Go client for interacting with GitHub. And I'm going to write this helper function, which plugs these values in, and I hard-coded the just ID here, but it could come from an environment variable or a file or however you want to define it. And it'll call that new plugin function with my plugin and my generate configs function. And if you look here, the generate configs function will use the client to talk to GitHub, and then it will pull the osquery config out and return it in that dictionary. So this is a very simple example, but you could do much more complex things. You could merge two sources of configuration here. So if you had, let's say you wanted to use some shared public system for pulling queries, but you also wanted to source queries that Puppet pushed to your system in a file, this is a place where you could merge both. If you wanted to talk to some weird enterprise system that had your configs, you could do that. So yeah, that's a osquery plugin for configuration, and that's all that you have to do. It's very simple because the SDK was written in a way to expose just that functionality that you need. And next, I want to talk about loggers. This is the part that is the most interesting to me because I see all the time people have these crazy logging pipelines where they will use Fleet to get their data onto a server and then use a Splunk forwarder to get the data somewhere else, and then they'll use the data from Splunk to get into a database and so on. And by the time they figured out how to get the data somewhere and maintain it, like they don't have the engineering resources to actually go and do the analytics they wanted to, because maintaining this logging pipeline is really hard and logging pipelines break. So what I want to pitch to you today is if you have a destination for your data, you should just send it directly from osquery because it's easy to do. Just how easy? That same library that has the plugins for config has a plugin for loggers. And the logger plugin, just like a config plugin, has a new plugin function that takes the name of your logger and some logging function. And the logging function looks like this. It's a function that accepts the log type, because osquery has a few different log types, like status logs and snapshot logs and so on. And you might want to send those to different systems, so you can make a decision in the function about that. And then you just log it, and you can return an error if you're having trouble connecting or something. So I'll show you an interesting logger, but before I do that, I debug osquery a lot, and I get annoyed by the file system logger because it logs to a file that I have to tail, and it also logs it logs structured logs in a way that I have to squint really hard to read them. And it's really annoying. So I built this logger, which all it does is it takes the logs that osquery gives me and pretty prints them to standard out. So when I work on debugging some table, some data, I usually use this as my logger, and it's only a few lines of code. Now let me show you a production logger. So I'm a big fan of GCP, the Google Cloud Platform. And if you use Google Cloud Platform, they have almost any Google product that you will use will log to a system called Stackdriver, which will accept JSON logs and protobuf logs and so on, and it will index them for you, so you can search them by specific keys and values and so on. And they have a good tutorial for writing your own logs in there, and this is their hello world example. You're basically defining a project ID, creating a logger, and then just logging anywhere in your program that you want. So let's transform this into an osquery plugin. So I define a plugin which takes has a logger configuration, and this is the cloud logger. And then I create a new function that helps me create this plugin and returns it. So in this case, the project ID is QueryCon 2019. This is my GCP project name. And I use the Google Cloud library to create a Google Cloud Logger client. So the login new client creates a client, and I use that client to create a logger. And I say this is my osquery result logs. It creates sort of like a topic that all your logs will go into. And then I return that plugin at the bottom. And then my actual plugin is this one line of code, which will use the logger and will write the log output to Stackdriver. And you can make this more complex because you might want to actually affect some of the format that the osquery gives you. For whatever reason, you might want to send status logs to a different channel. Your choice, what you're doing there. But this is how I get my logs into Stackdriver. So this was the development logger that I showed you. And this is the production logger that I'm showing you. And they look pretty much the same, just as easy to write one or the other. But this one is actually very useful. And so my logs are now in this system that I can query, and I can filter by different fields and so on. I can also, there's also two buttons at the top. One will allow me to create a time series based on some event, so I can actually create alerts because a specific log type triggered it. I can also export it to other systems being like Google Cloud Storage or S3 and so on. And something that I'm working on, just kind of a diversion, is exploring this idea of using business intelligence tools that exist that your marketing team, sales team probably use to get osquery data into them and then reporting them and create dashboards. So I'll write a blog post about this. Once I figure it out, I'll probably spend some time in the workshop tomorrow with that. But take your data from osquery, add it to BigQuery Data Studio. AWS has some similar things with, I think the products are called Redshift and Insight or QuickSight or something like that. But this is the result of, so I went from this to this in about 15 minutes. And once the plugin exists and you have your data, you can query it across your entire fleet and get all sorts of charts and things like that. So I didn't have to create a custom product just to see osquery data. I could just import the osquery data and use tools that already exist. And there's no logging pipeline. Yeah, so I've shown you how to write a few plugins so far, but I haven't actually shown you how to run them in osquery, so let's do that now. I've used the words extension and plugin interchangeably. They actually have very specific meanings in osquery. So a plugin is what I've shown you so far. It's the bit of code that implements a logger, a table, or a config plugin, or also the distributed, or also known like live query plugin. That's also a plugin you can write. And those are plugins. Now, an extension is the binary that will contain that code that osquery will run to actually be able to use the plugins that you wrote. So osquery, the extension is the binary. The plugin is the functionality that you're adding. And so this is what it looks like in my main for my binary. There's a few flags that you have to define. And these are and they have to be those specific flags: socket, timeout, interval, and verbose. The reason you need to have these flags is because osquery will actually be the parent process that calls your binary and it will call them with those arguments. So in most flag parsing libraries, they will fail if you provide a flag that you don't know. So you have to define them, even in cases when you're not using them. You should probably use all of them. So going down further after parsing the flags, the osquery Go library has something called the extension manager server. You will have to create it, giving it a name, a unique name for your extension. And the Unix domain socket path that osquery will give you when it starts your extension. And then there's some optional arguments like a timeout in case all of this blows up, or in case you're running on Windows where everything starts really slow. The values, tuning those values can be super useful. Assuming everything goes well, you can start using your plugins. So here I am creating these 3 plugins that I've described so far. And then I register each one of these plugins. And finally, I call server.run, which will run my extension until it's terminated or it exits with an error. So the log.fatal there is in case this run returns some error. And that's it. This is what goes in my binary. There's some interesting things that I'm not going to talk about, but I'll mention, which is figuring out how to do configuration for your things like API keys and so on. I use environment variables, but there's other ways of doing that. And also, one of the other reasons I really like Go is that it has good support for working on different platforms. But if you're building a single binary across different platforms, you have to be aware of like what functionality, what system calls are available everywhere. So Go has build tags, and you can kind of structure your plugins in a way where you can compile the same binary for different platforms. And I've explored a lot of that while we were working on Launcher. And Launcher is a really great tool, even if you're not using it. If you want to write osquery extensions, I recommend reading the source because it explores a lot of these problems and like how to structure your code and so on. So that's it as far as code, but we still need to make this run. And osquery is kind of quirky with how it starts plugins. So plugins need to be named with a .ext extension. The .ext file extension. And so when I build this binary, I'm building it specifically with that, except if you're on Windows. On Windows, it's .exe. But on Unix, it's going to be .ext. And once I build it, I'm also putting the path into a file called extensions.load. When you're deploying in a production environment, you wouldn't echo the build folder. You would have a package where you're deploying this binary. But you have to also deploy a file that specifies the path to where osquery can find your extensions. And osquery uses this .load file. My next target here in this make file starts osquery.d with this extensions.load file. I'm also using these arguments for PID file, database, and extension socket. I'm just doing this because I don't want to overwrite my actual osquery deployment, and temp is good for development. And these are good flags to be aware of, especially the socket, because you're interacting with extensions. And then finally, I have 2 flags for configuration. I wrote a custom config plugin, so I have to tell osquery to use that. I am not using the other flags because they are provided once the config is fetched from my config plugin. They're still available in that JSON blob, so my logger plugin and so on. And like Zach mentioned, you have to be aware of things that your remote server or like your config plugin can actually change at runtime, and flags that you need to run when starting osquery. So this is how you launch an extension. I'm not going to talk about tables today, but I will mention one more really awesome bit that osquery offers, and that is the ability to use the API to run queries. So normally, I see a lot of scripts, especially in IT, where people will call osquery I, and it will exec it every time they want to get a query because osquery already has a lot of interesting tables that you can use. But one thing that I would like to see more is people using the Thrift API to do this, because whenever you shell out to osquery, you're incurring a cost that you don't have to incur with the Thrift interface. So this is what it looks like. You once again have a binary with a flag for the socket path. And then this time, instead of creating extension server, you're creating a client which will talk to osquery. And this client has a very simple interface of running calling query as a method and providing the actual string that you want to run a query as. So if you wanted to use osquery but build a whole new interface for interacting with it, like maybe a local desktop app that queries osquery, you can do this. I've started using this for Monkey, our software management tool for Mac OS, which has something called conditional items. So you can say, like, I want to install Adobe Photoshop only if this person has a license, and osquery can tell me if this person has a license already through some means. So interfacing with them, the Thrift plugin is really nice. And this is all you need to do. You just go client.query, you get back a response. The response is going to be familiar to you. It's just it's a map of values. And then you can use your values in your code to do whatever you want. So that's the other way of interacting with osquery. As I mentioned, osquery has tables, config plugins, loggers. It allows you to write distributed queries, or we also call them ad queries and ad hoc queries and so on. Live queries and ad hoc queries. And then it also has a way of you can query osquery to get the results of a query through this API. The query one actually also has a really cool method called columns. I can give it any query, like no matter what tables and joins and so on, and it will tell me what the columns that are going to be returned are. It will give me the schema of my response without actually running the query. And I found that very valuable in some ways where I want to have a system that programmatically can detect the schema that's going to be returned to me. So that's a cool trick that you can use. I wrote a blog post a few years ago that is a tutorial for how to write extensions, and it goes into the examples I've shown you here. It also includes a live query plugin that uses Twitter, so you can message a Twitter client and get back results from a bunch of computers. It's just an example. And it also talks about tables. I think I implemented a systemd table. And the code for that exists on Collide/Go extension tutorial. And it has the make file that I've described, and it has all of these plugins in the extension. Feel free to reference it and so on. And this is me on GitHub and Twitter and so on. Thank you for listening to me. And,